Hello everyone and welcome to our webinar session in regard to smart air injection and an efficient solution for your conveyance of dewatered sludge. So my name is Stefan Mottul. I'm a product manager for smart air injection, and in this function I would like to present to you today this presentation, which is called Revolution for Dewatered Sludge Transportation, Smart Air Injection for Minimizing Your Lifecycle Costs. But let's come first to the content of this webinar session. I would like to start with a short motivation of this topic. So why has SEEPEX investigated this new conveying technology? That is followed by a short description of the conveying concept and also the SAI logics and the control strategy. And then we switch over to the practical part, where I would like to show you some of the references and also two case studies that we have drawn in Stadtwerke Seele in Germany and also at Thames Water in Reading, where we've also investigated the TCO and the savings that we could achieve by these systems. But let's start first of all with the motivation. So where have we investigated a new product for the conveyance of dewatered sludge? That comes from the market that we see increasing requirements, especially due to the newer EU regulations for fertilization and sewage treatment or sewage sludge regulations. We see that the processes, the common processes of handling your dewatered sludge is changing. So phosphate must be regained, and also it cannot go to the landscape anymore because due to nitrate loading in your grounds. And we need to go to incineration more and more. So these established processes that we have on our plants are changing. And since the building density of most of the wastewater treatment plants is rather high, it quite often occurs that longer distances has to be conveyed and also has to be conveyed with the dewatered sludge. Another aspect that we see is here that life cycle costs are more often considered, especially by the larger water authorities, and that's directly concerned or connected to energy efficiency of your equipment. And especially for the larger equipment that is on your plant, easy and fast maintenance is always an issue because it is always related and connected to the downtime that you have in your processes. And to be able to handle and stay with your process, maintenance is always an issue and important. And our solution to this is a combination of two known technologies, which is pumping by a progressive cavity pump. So that's really for SEEPEX or bread and butter product on skill. So it's here a hopper pump that is conveying the dewatered sludge, and it's combined and supported by a pneumatic way of conveying, which we call pneumatic dance phase conveying. But let's come first to a comparison with the conventional way of conveying dewatered sludge to see the benefits really of SAI. The challenge in conveying dewatered sludge lies in the high viscosity. And this high viscosity leads to the fact that we have rather high pressure losses in our pipework by the way of usually pumping it through the system. And that, in the end, we are restricted by this pressure losses in the distance that we could convey, because the pressure is more and more increasing, and in the end you need very large high pressure pumps to overcome this pressure losses, and high pressure pumps come always with a large engine, a large motor, and consumes a high amount of energy. And on the other side, from the plant, you need high pressure rated also for all your piping and your equipment, which is quite expensive on the investment side. If you compare this to smart air injection, the main benefit and feature we can generate by SAI is that we bring down the discharge pressure to a very minimum of only 2 to 3 bar. And that's achieved by this discontinuous way of conveying the medium in plugs. So plugs of dewatered sludge are generated by our pump that is conveying here the medium into the discharge pipe. We surround it by a lubrication fluid, which is usually polymer solution that's always present on your plant. And then we build up here this 10 to 15 meter plugs of medium, and then once accelerate those plugs by pneumatics. So we use the pneumatics to convey it further down the line and shoot it, this packages of dewatered sludge by pneumatics. And that is here very purposefully used, very short term only air is consumed, and helps us to reduce the pressure inside your pipework to a minimum of only 2 bar, because we reduce frictional losses. And that leads to the fact that we have here only a small pressure pump that must be applied, which comes along with a very small engine and motor. And in the end, also on the other side here in your plant, you can also apply very low pressure rated pipework, and also plastic pipework can be applied for multiple hundreds of meter conveying distance. In the end, what are the benefits that you receive? We reduce your operational costs significantly, because the total energy that must be consumed for an SEI system compared to a conventional solution is highly less. And also the maintenance costs could be reduced because spare parts are small, spare parts are cheaper, and due to the small pressure, the lifetime of all the components is highly increased. Another effect is that we reduce your investment costs, since all the pipework and all the fittings is only low pressure rated in PN10 compared to conventional solutions that always or often come with PN100 and even more. We have achieved here a right flexible pipework that could be planned on your plant. So multiple bands is not an issue for us, and also vertical elevation of up to 30 meters and more could be achieved by smart air injection. And we achieve also here a very long transportation distance due to the fact that we use here pneumatic dense phase conveying. We could achieve 1 kilometer of transportation distance, which is not possible with any other computational solution. We reduce the downtime of the process because we come with a solution, a small pump that has maintenance in place abilities, so you could exchange any wear parts on service issues in less than 1 hour and without any dismantling of pipework. And since we only act against 2 or 3 bar of pressure, the lifetime of all components is highly increased. We have pneumatics in our system, and that's why we also have the ability and the possibility to have pipe cleaning before longer downtimes, and especially in the winter time where you need usually backup heating for your pipe work before longer downtimes. That's not required with an SEI system because we blow free by pneumatics and by air the entire pipe work before longer downtimes in the weekend. And if you restart on Mondays after in the winter, it's not an issue and you can restart your process without any backup heating, which is also a good benefit on the investment cost side for your plant. And if pump footprint or place or space is restricted in your plant, we come here with a very small pump. It's only around 2.5 or 3 meters compared to high pressure pumps that are all often 7 meters or even more. If I tell you now that we have a pneumatic system that is very efficient, you might say, I don't believe you. And that was also my first reaction, because what I've learned also in university is that compressors are nearly the worst case scenario on efficiency, because nearly 90% of the energy goes to heat. But you have to distinguish between the different types of pneumatic conveying to see why it could be efficient. So usually we split here between 3 types of pneumatic conveying, which is lean phase, where granular powders are blown with constant air and at very high velocities through your pipework. So that's rather not efficient because you have a high amount of air that must be consumed in regard to the material that you convey. Then we have an intermediate phase conveying, where you have a swimming bed of medium on the bottom of your pipework, and above you have this type of lean phase conveying. Also here the ratio of air to medium is not the best. And what we really use here, and the only way which could be efficient, is dense phase conveying. So where you pre-compact packages of dewatered sludge that are then by purposeful and short air injection accelerated and shooted down the line like pneumatic post system. And we even increase the efficiency of these systems by lubricating those plugs with the already present polymer solutions. So we build up a layer around those plugs in order to reduce the frictional losses by the pneumatic conveying. Another effect that we make use of is the shear thinning rheology of both fluids. So both the dewatered sludge and also the polymer solution is highly shear thinning. And shear thinning means, like the name is telling you, under high shear rate, the fluid gets thinner and more easy to be flowing. And that is here directly expressed by this diagram. So the viscosity is decreasing the more you are shearing your fluid. And that's what we really need, and that's what we use here on these cases. Because the interesting point and the important point is that the shear rates are directly proportional to the velocity inside your pipework. And if you see how where the high shear rates occurring in your pipework, that's where you have the high velocity gradients here. And directly in the boundary layer of your pipework, where the high frictional losses occur, we have the highest shear rate. And if we then accelerate those plugs by SEI, we increase the shear rate at these locations where the pressure losses occur. And if you compare now in this diagram, the usual way of pumping, which is acting at very slow velocity when the medium is moving by 0.05 meter per second through your pipework, we are in this region where the viscosity is rather high. And for high dewatering content, you speak here about 500,000 MPa that could be achieved. But if you accelerate those plugs of medium to very high velocities of 5 meter per second, you reduce on the same time temporarily the viscosity here in this boundary layer region of your plugs, where the high shear rates occur. And the factor 10 in reduced viscosity goes directly proportional to the pressure losses, and that's what makes this system so efficient. And a good example to demonstrate this effect is ketchup. It's a children experiment that usually you do at school in physics, where you put a golf ball of ketchup on top of your bowl of this ketchup fluid, and due to the high viscosity it's stocking on top. But if you let this golf ball fall from a certain distance into the bowl of ketchup, then it's fluidizing this ketchup, because due to the high shear rates that are coming to this medium on impact by the golf ball on this layer. And that's what we use here really by our SEI system. Let's look to the process. So how does it look like when the process is started? At the beginning of the conveying, we have nearly zero pressure inside our discharge pipework. And then only the pumps are moving and working and generating this plug material inside the discharge pipework. The pressure signal is successively here increasing inside your pipework. So that's here really a measurement signal that we have drawn in a plant in Sweden. And if we once reach a region where we say, okay, the plug length is nearly optimum for our conveying process, then we open up the sonoid valve, flute the system by 10 bar of compressed air. And this is then once overcoming the frictional forces of this plug and once accelerating it. So we see here a pressure peak in the signal, and then it moves down the line, is accelerated to these high velocities until it reaches a destination, which is here inside a silo bottom. And if the pipe is again free, you see that the pressure is decreasing to a very minimum of nearly zero pressure, and the process restarts again. So let's summarize. How does it work? And how could we reach this very, very low pressures inside the pipework? That's due to 3 reasons. First one, we use a lubrication of those plugs in order to reduce locally the frictional losses in the pipework. We make use of a pneumatic way of discontinuous conveying, which is called dense phase conveying. And we make use of the rheology of our fluids, which is shear thinning, and the viscosity is decreased temporarily under high shear rate by this conveying process. And in the end, this leads to a very good efficiency, and that we only use very short-term and infrequently air inside our system, which is roughly around 1% of the total time. We have started at the beginning to investigate the limitation of the systems, and we go with a temporary installation to a plant in Sweden, where we have here inside this building a dewatering unit, and we have bought a plastic pipework of only PN16 pressure stability, and we have put it on the ground and have here a routing of this pipework of around 500 meter distance, where we've then started the conveying process and look how it looks like after multiple injections of air and what comes out in the end. And if you look now to the pipe outlet, so that's here really after 500 meter, the outlet where the plugs are then shooting on the field, and that's here after the injection of air, one plug that gets out and is shooted onto the field, and that's how it looks like when it comes out. So it works also for 500 meter, and also for this case here, we have not reached more pressure than 5 bar, so we are not at the real limit to convey here dewatered sludge on a distance of up to 1 kilometer. The pump type that we use is a pipe that we call BTHE, and the BTHE is a pump that is designed to handle a high dry solid content up to 40% of dry solids. And that's done here by a concentric ribbon screw that is inside our hopper element, and this ribbon screw acts also like a bridge breaker, so bridging is ensured that it does not occur, and we can handle here and push the high dry solid material into our pump elements, rotor and stator. The capacities that could be handled by smart air injection range from 0.5 cubic meter per hour up to 30 cubic meter per hour. And if we have new installations, we would like to recommend stainless steel installations or even plastic piping like HDPE, which must only have a pressure stability of PN10. If you have retrofit solutions, we have also retrofit ability, but nevertheless, we must prior check your application, check your pipework, and we have also some installations that go only by steel pipework, but that must be investigated by ourselves, case-to-case decision. For easy maintenance, we have two different types of technology. First one is our patented smart conveying technology, which is also called SCT, and which is the patented split stator. So the rubber element of our pump, the stator, is halved, that you can very easily get access to rotor and stator and exchange those wear parts and elements on wear occurring, and are very highly reducing the downtimes in your system. An alternative that we offer is a sliding compression case, where you can easily dismantle here the compression zone and get access to the rotor joint, exchange rotor and stator, and rebuild everything again. And all those both technologies can be serviced without any dismantling of the pipework. So you are quite quick. You have only a very short duration of downtime. The application range that we can handle here with SEI is nearly all systems that could be handled. We have screw presses also fitted with SEI. We have belt filter presses that are used for dewatering and used with SEI conveying. We have filter press installations and also centrifuges. We have used SEI to feed into a silo and also to use it as a silo discharge pump, which is placed below the silo. And we have also some installations which are put below a reception bunker, and where then the imported sludge is further conveyed by smart air injection systems. So nearly the full application range of handling dewatered sludge could be handled by smart air injection. The control logics comes all on a so-called SEI controller. So what we offer here from SEEPEX is a full package unit. And package unit means it's a partially automated system product. And we include here all machines that are required, all the functional components like sensors, actuators, and also the control logics, and all is fed here into this SEI controller, where a full visualization of the process runs. We have also here monitoring capabilities and the fault diagnostics. And this system fully controls itself in regard to flow rates of sludge, of lubrication, and also the air injections are triggered with an optimization algorithm to achieve here best energy efficiency. The safety functionalities are ensured for this system by our control logics, and this could be very easily integrated into your superior control system by the common feed bus signals. We have also a second type of implementation of this controller logics, which is on Siemens, and which is also pre-compiled component software parts. So if you have already a Siemens controller in your system, we can easily upgrade this controller by our Siemens logics, and you then run our SEI control logics on your own PLC. This SEI controller could also be easily integrated into connected services. This enables you to also by Bluetooth signal get access from everywhere with your mobile phone to the data of your system, how it runs. It enables you also to get a mobile notification service, so overnight or for the service team, that it gets a notification, a warning on high wear, on any issues that might occur on your system. And if you have multiple systems that are monitored by our pump monitoring systems, we can also go into the cloud, where you have then an overview about all the pumps that are running under your pump monitoring system. You can get access to every pump that is running and see some historical data, trend analysis of the pressure, the flow, and also the hydraulic power. And we have also the capability with our advanced analytics to do an anomaly detection, to define separate KPIs to investigate your system. And you have also the possibility to have a wear indication where the pump operation is compared to the characteristic curve, so you really know about the wear status of your equipment. And in the end, you will receive a reporting every month, where you get a quick overlook about the performance of your system, about maintenance issues, protection issues, and also, if required, on the entire process that is running here in your system. Let's come to the more practical part, SEI installations. We are now, since 2017, on the market with smart air injection. Until 2017, we have now installed more than 50 systems in the market, especially here in Central Europe, where most of the systems are in the Nordic region, in Germany, in UK, some in Italy, France, and also the Belgium and Netherlands. But let's go into detail for some of those reference plants. Liesekill was one of the first installations that we have done. So you see here we have a screw press that is dewatering the sludge onto a content of 22%. It's then further conveyed by our SAI system into the silo, and the distance is not so long. It's only 25 meters with a capacity of 1 to 3 cubic meters per hour. The interesting thing here is that we go out of this building here and then by the pipework from the site into the silo installation. And what we here really see is an adaptive algorithm that we have triggered. Independent of the fill ratio of this silo, we have adapted our parameterization of the system in order to optimize the energy efficiency of the system. We have here another installation in Sweden, which is in Strängnäs, where a centrifuge is used for dewatering the sludge onto a dry solid content of 24 to 27%. And then it goes here out of the pump, is split to 2 different routes, pipe routes. And we have also integrated this valves into our control logics. So by the controller, you can decide if you would like to feed route A or route B. And then it goes in an underground pipework out of the field, and it's here fed onto a ground storage location. That are the 2 locations where we can decide where the sludge should be conveyed to. 35 to 55 meter, and the capacity in this case was 4 to 8.8 cubic meter per hour. Another installation in Hallsberg, Sweden, is also where we have a split directly after our pump to 2 different locations. Also here we have a ground storage installation and an underground piping of 50 to 70 meter. And the interesting thing here is also that you see we have a very large cone that occurs for this underground conveyance. So you need very few points, outlet points on the ground storage. And you have here a diameter of this circuit, which is around 30 to 35 meter. So a good distribution of your sludge on an open area. Another installation here in Belgium, in Genk at Aquafin, is where dewatered sludge is dewatered by a centrifuge to a content of 26 to 30%, and it goes from this pump installation out of the building and directly into a silo. Here was interesting that we have 2 different types of silo feeding, one from the bottom of the silo and one where the pipe is running out of the silo to the top and is entering. Here's a sludge onto the top location, and we've done an investigation on the energy efficiency and find out that the most efficient way for SAI to convey into a silo is to go outside the silo onto the top and feed the silo from the very top. A temporary installation, also quite interesting, here in Heerenveen in the Netherlands, where we have a 3-month installed mobile unit here of a centrifuge that is running on a truck. And from this centrifuge, we bring it out into our pump installation. We've installed the scaffolding, which goes up here to the silo, and a plastic pipework that was also temporarily installed. And after the pump, you see here our spool piece installation, where the lubrication fluid comes here on a circumference into the pipework, and we have here the solenoid valve where air is injected. This runs for 3 months. The distance was roughly 60 meters in a plastic pipe, and the capacity ranges here from 1.5 cubic meter up to 3.5 cubes per hour. Another installation at Veolia Water in Osbaistown, Ireland, was here also with centrifuges. Dry solid is 26%. And the interesting thing here is that we have a complex type of pipe routing. So we have here 3 centrifuges installed in parallel, where we see here one of the first pumps where the pipework goes out. We are injecting air at this vertical pipe location, and it goes here to one main pipe. We have in the background also a second pump where a centrifuge is placed on top, and also this here feeds into the same main pipe. And from the back, you see here that also one pipe is coming from the back location, where we have a third centrifuge that is feeding here into the main pipe. This main pipe goes straight through the building and is here coming out of the building, and is then split onto 2 different silo locations. So this is all integrated into our control logics, and you can decide on the SEI controller if you would like to run centrifuge A, B, or C, or if you would run 2 in parallel, and also if you would like to feed onto the silo 1 or into the silo B. The piping distance is only 35 meters, and the capacity in total is 6 cubes per hour. But we have received a very good feedback from Alan Whitty, and we could also denominate him here as a reference, which sent us per mail a good comment that we could place here. So he's now handling for 17 years sludge cake pumping, and he was extremely impressed by this SEI installation, and it has fundamentally changed the way how we would approach sludge cake transfer and design in the future. Let's come now to the last part, which is the case studies. And first of all, we have here one in Seende in Germany, where we have also quite long distance of transferring dewatered sludge, around 250 meters. It was a totally new installation, so this building, the dewatering unit, was totally new, built up, a centrifuge here on top that feeds into our hopper pump. You see here the lubrication hoses coming from the sides into the system, and from top here the solenoid valve where air is injected into the system. The pipe routing is quite interesting because we go out of this building here. We have many bends where it goes around the building, and here at the star location we are going to the existing pipework, which is made of steel, and then we go in an underground pipework straight down the line and below Billabach, a small river, and then we can decide here by 2 diverter valves if we would like to feed on sludge hole 1 or sludge hole 2. The initial installation was a piston pump with 45 kilowatt that was replaced, and the customer hurt point on this position was really that he has some pain with the high maintenance costs of this installation, which ranges around 15,000 euros per year. The challenge really was for this installation that we have to reuse the existing steel pipework, and initially we have done a camera inspection and pipework looks quite well, that we decided to reuse it. After the installation and half a year open to atmosphere, we have done a second investigation, and that's your picture from it. So you see it was highly corroded. That was quite challenging for the SEI system. Nevertheless, we have arranged it, and this system is running since 2017, December, and the customer is satisfied. We have replaced no components since then, and that's here how the pressure signal looks like. So you see that we inject air. The pressure signal is increasing on the different locations at the different inspection chambers down the line. And if we enter then sludge hole 1 or 2, in the end, the pressure is again decreasing to nearly 0, and the solenoid valve closes again, and air injection is done, and the sludge is conveyed to the destination. And all is here done except that we have 250 meter on a pressure level below 1.2 bar. So let's look to a video. How does it look like when it enters the sludge hole? So you see here behind me, it's like a mole throwing hill that is breathing, and that's really how it looks like. I do it again, when a sludge plug is entering the sludge hole location. We have also done a TCO, so life cycle cost analysis, together with the customer, and have investigated the initial costs of the piston pump in regard to maintenance, lubrication costs and power, and compared it to the current situation where SAI is combined with the existing steel pipe work. You see that we consume at the moment a rather high amount of lubrication. Nevertheless, it's nearly half of the amount that was required on the piston pump installation, but that's only by the corrosion that is at the moment present in the pipework. If we would go here and improve it even more with a plastic pipework and new installation, we could achieve a higher saving potential with this system. And in the end, we have achieved here a maintenance reduction already at the moment, around 88% in maintenance costs, and the energy costs could be reduced by 50% compared to the piston pump solution. If we accumulate the cost saving over a duration of 10 years in operation, the customer is able at the moment to save around 250,000 euros by changing to the SAI installation. And if he would even go here for the plastic pipework and improve his system in the future, he has an additional potential to save 100,000 euros in addition. Let's come to the second case study that we have done, and that was a temporary installation at Thames Water in Sweden. It was an existing plant where we have already 5 years ago exchanged a piston pump by a multi-stage high-pressure progressive cavity pump. And we have temporarily installed here our control logics of SAI combined with a mobile compressor unit and with our control logics for injection of SAI. At this installation, we were able to combine 3 different systems, which is here the first one, the piston pump solution, which exhibits high amount of maintenance costs and energy costs, the current installed multi-stage high pressure pump solution, and here on the left side you have the SAI installation. And we were able to achieve here a reduction in maintenance costs of around 80%, and also energy costs could be highly reduced by 72%. Let's summarize the application. So what can we do with smart air injection? It's especially designed for the conveyance of dewatered sludge in the wastewater industry. Nevertheless, we have already applied it for different other applications, quite successful also for the brewing and distilling industry, where we have used it for the conveyance of spent grains and spent hops. We have also used it here in the renewable energy and biofuel industry for the conveying of spent grains, and also for the malt vinegar production in spent grain conveying. Waste food with a BTM pump we have also combined in an SAI system, and we're able to convey a mixture of waste food. But in the end, our main application is the conveying of dewatered sludge. And the features that we enable here for you is a package unit where you get all the functional components like pumps, air components, sensors, and actuators, which are integrated into our control logics. The SEEPEX services that you receive are here the full clarification of your application. We customize the system to your needs. And if you require a retrofit, we are also able here to upgrade your system with an SAI system. Let's summarize. SAI is an intelligent conveying concept that enables you to convey medium up to 1,000 meters of conveying distance. It helps you to reduce your operational costs in regard to power consumption and maintenance costs. We could reduce significantly your downtime because due to the very, very low discharge pressure of only 2 to 3 bar, because we have an increased lifetime of all the pump components, and also we enable here by easy maintenance concepts, maintenance in place, which takes you only 1 hour maximum for every service work. The investment costs could also be reduced because you need only this very low pressure rating of PN10 instead of PN100 or even more. And we enable here also process monitoring and optimization with our SEEPEX connected services. If odor or spillage is a problem, here the system is completely encapsulated. It's a closed system, and we have here integrated also a pipe cleaning capabilities. So if we have on longer downtimes in the winter, the problem of freezing, you don't need any backup heating for your pipe work because it's blown free by air after every run, and then you can rerun it after longer downtimes quite easily. Thank you for your attention. And if you have any questions, please contact me. Yeah, I will try to answer as many of those questions as I can. Thanks a lot. Stay healthy and goodbye.